Structural equation modeling, or SEM, is not one technique but a collection of flexible multivariate techniques. SEM examines a set of relationships between complex and multifaceted constructs. There can be one or more independent variables and dependent variables that can be either factors or measured variables.
Think of SEM as a web of correlations and regression slopes, making predictions in an outcome based on independent variables collectively used to make inferences in a dataset. SEM can also be called causal modeling, causal analysis, simultaneous equation modeling, analysis of covariance structures, path analysis, or confirmatory factor analysis.
SEM is a confirmatory technique that requires the researcher to specify a model. The model is a statement about theoretical relationships between variables. Through SEM, the model can be estimated, evaluated, and perhaps modified.
The goal of the analysis is to test a theoretical model against observed relationships between variables in your dataset. SEM can test specific hypotheses about a model, modify an existing model, or test a set of related models. You are comparing the statistical fit of an SEM-generated model to the actual matrix from your dataset.
Parameters are constants that indicate the nature and size of the relationship between two variables in the population. We can never know the true value of a parameter, but statistics help us make our best guess. If the model is good, the parameter estimates will produce an estimated matrix that is close to the sample covariance matrix.
Another important term is latent variable. A latent variable is a factor or construct that is not directly measured but rather assessed indirectly because they are difficult to measure and are essentially unmeasurable. In the model, a latent variable can have two or more indicators and is typically represented by circles or ovals in the path diagram.
Measured variables, which are also called observed variables, indicators, or manifest variables, are represented by squares or rectangles in the path diagram. Measured variables are directly measured, so they include measurement error and other variance not related to the latent variable of interest.
Path diagrams allow the researcher to diagram the hypothesized set of relationships in the model. The diagrams are helpful in clarifying a researcher's idea about the relationships among variables, and they can be directly translated into the equations needed for the analysis.
Variables used in an SEM include latent, measured, independent, dependent, and intervening variables. An SEM can be used to test hypotheses about relationships between variables, specifically when working with numerous independent and dependent variables, or when they cannot be measured directly.
SEMs can answer many questions, including how much of the variance in the dependent variables is accounted for by the independent variables? Does an independent variable affect the dependent variable directly or through an intermediary or mediating variable? And do two or more groups differ in their covariance matrices, regression coefficients, or means?
Assumptions of an SEM include adequate sample size, multivariate normality, linearity, the absence of multi-collinearity and singularity, and residuals being small and centered around zero.
Limitations of an SEM include the necessity of having prior knowledge of potential relationships among variables. Additionally, there is nothing causal about the use of SEM, and results can only be generalized to the type of sample that was used to estimate and test the SEM model.
Let's look at a fun example. You are a big traveler and want to compare someone's willingness to travel to Africa to their satisfaction with a safari. Both of these would be latent variables because they cannot be measured directly. Willingness and satisfaction would be made up by measured variables.
Willingness to travel to Africa and satisfaction with the safari, which can be looked at as two dependent variables, share two measured variables, accommodations and cost. Satisfaction with the safari also has a few other independent variables: the tour guide, the number of animal sightings, and interactions with other safari tourists.
Additionally, willingness to travel to Africa has some of its own independent variables: the language barrier, health considerations, and access to legal requirements. You would predict, using theory, which variables have relationships and run the SEM to see if the observed relationships are what you predicted.
Algazine et al. Used SEM to examine the relationship between social behavior and academic achievement in elementary students who were deemed at risk for academic failure and developing emotional or behavioral disorders. Research questions considered the similarity between actual student levels of reading and behavior and teacher-rated measures of student reading and behavior.
SEM was used to examine the relationship between latent variables, which were student reading achievement, social skills, and problem behavior in second and third grades. SEM was further used to determine the goodness of fit of the data to the hypothesized model between reading and behavior constructs.
Results suggested that the data supported the model across reading and behavior, but did not provide enough evidence to support the significant relationship between reading and behavior measures. Also, teacher ratings of academic competence were related to teacher ratings of social behavior as well as to actual academic performance.
To summarize, teachers are more likely to rate well-behaved students highly on academic competence. Students who demonstrated more social problems were believed to be less competent in academic study. However, the actual relationship between academic achievement and social behavior was weak.
To learn more about SEM, you can take a class entirely devoted to the topic. Psych 622 SEM for the Social Sciences should be offered in spring of 2019. Information can also be found in Chapter 14 of Using Multivariate Statistics. Two online resources are statsoft.com and statsmakemecry.com.